All right, so here we get started with our graphing exponential functions notes. So you should have just finished your exponential rules quiz, and now we're going to talk about graphing these kinds of functions. Okay, so graphing these functions, how we typically would. So we're going to first fill out our table, and then we're going to plot those points. Okay, so for number 1, we have y is equal to 2 to the x. Okay, so that's y is equal to 2 to the x, and we want to find when x is negative 2. What's our y value? Okay, so we would have 2 to the negative 2. Remember, with negative exponents, it moves it to the bottom, so we have 1 over 2 to the 2, which is 1/4. Okay, so we then plot that, so we're at negative 2, positive 1/4, so approximately somewhere right there. Okay, so then we have 2 to the negative 1, which would become 1 over 2 to the 1, which is just 1 over 2. So at negative 1, we're at a point of 1/2. Okay, 2 to the 0. Anything raised to the 0 power is 1. So when x is 0, our y is 1. 2 to the first is 2. So when x is 1, y is 2. 2 squared is 4. So when x is 2, y is 4. 2 cubed is 8. So when x is 3, y is 8. And then 2 to the 4th. So when x is, which is 16, so when x is 4, y is 16. So then we can graph these by connecting, and it should be a curve. Okay, and we draw our arrows on the end. Okay. And then lastly, okay, so now we do the same thing for y is equal to 3 to the x. So now we have 3 we have 3 to the negative 3rd, which is 1 over 3 to the 3rd, which is 1 over 27. So when x is negative 3, we're really, really small at 1 over 27. Okay, so then we have 3 to the negative 2, which would be 1 over 3 to the 2, which is 1 over 9. So when x is negative 2, we're a little bit bigger, but not much. Okay. Then 3 to the negative 1, so 1 over 3, so a little bit bigger, but still not much. So when x is 1, 3 to the 0, again, anything raised to the 0 power is 1. So when x is 0, y is 1. 3 to the first is 3. When x is 1, y is 3. 3 to the second is 9. So when x is 2, y is 9. And then 3 cubed is equal to 27. So when x is 3, y is way up here at 27 somewhere. So we run along, we curve again, and there's our exponential function. Okay, at this point, pause your video, and I want you to try questions 3 and 4. You should have just paused the video and completed these 2 graphs, and here's what your 2 graphs should look like for y is equal to 1/2 to the x and y equals 1/4 to the x. Okay, so as we're looking at these graphs, we want to notice a relationship between our equation and what's happening in our table. So if we look back at the first 2, how did we go from 1 to 2? Well, we multiplied by 2. How did we go from 2 to 4? Again, we multiplied by 2. 4 to 8 by 2, 8 to 16 by 2. Here, if we look at number 2, from 1 to 3, we multiplied by 3. From 3 to 9, we multiplied by 3. From 1/3 to 1, we multiplied by 3. Okay, so our relationship between our equation and what's happening in our table is that the base, or the number that's being raised to the exponent of the exponential equation, is the number you multiply an output by to get the next output. Okay, so for example, 16 times 1/2 is 8. 8 times 1/2 is 4. 1/2 is our base. That's what's being raised to the exponent. That is our base. Okay, go ahead, pause, ask questions if you need, and then go ahead and flip to the back page. Okay, so here we're going to do the same thing, only now we have one additional step. Not only are we raising it to a power, but then we're multiplying it by another number. So for example 5, we have 3 times 2 to the negative 2. Okay, 2 to the negative 2 was 1/4, so we have 3 times 1/4, which is 3/4. Okay, go ahead, pause the video, and complete these next two examples. If you're still confused after pausing the video, I'm going to go ahead and work through question 5 with you. Okay, so we did the first one, so now we do the same thing for the second. So we have 3 So then we have 3 times 2 to the negative 1, which is 3 times 1/2, which is 3/2. Okay, then we have 3 times 2 to the 0, which is 3 times 1, because remember 2 to the 0 is 1, so we have 3. Okay, and then we have 3 times 2 to the 1, which is 3 times 2, or 6. We then have 3 times 2 squared, which is 3 times 4, which is 12. Then we have 3 times 2 cubed, which is 3 times 8, which gives us 24. And then lastly, 3 times 2 to the 4th, which is 3 times 16, which is 48. Now at this point, go ahead and graph your points and continue on with questions 6, 7, and 8. So here's what your graph should look like after graphing number 6. Okay, we have 2 times 3 to the negative 2, which is 2 times 1 over 3 squared, which would be 2 times 1 over 9, which is 2/9, so on and so forth. Okay, here's examples 7 and 8. Again, we plug in our x values and we get our y values. Okay, so then we want to look at what do you notice, or any relationship between our equation and what is happening in our table. Okay, well, let's first look at when x is 0. Okay, just looking at these two examples. When x is 0 in number 7, y is 4. When x is 0 in number 8, y is 8. Okay, and from the equation, that's our first value. So in our equation, when we have y equals a number, that number is our y-intercept. Okay, it then multiplies another number that it's being raised to a power, or to x. Okay, and to get that number, just like before, that's the number that we multiplied by to get to the next number. Okay, so 16 times 1/2 is 8. 8 times 1/2 is 4. Right? So this number inside the parentheses or with x is what we multiply by one output by this number to get the next one. To get the next output. Okay, so we multiply the previous output by our number or by our base to get the next output. Okay, go ahead, pause this video, explore and see what that means. So here's our last little bit. Each of these functions that we just graphed are called exponential functions. And an exponential function is in the form of y equals a times b raised to the x, where a tells us the y-intercept of the graph, and b tells us what we multiply by to get from one output to the next as x increases by 1. Okay, now we do have a couple of stipulations. Okay, a cannot equal 0. Otherwise, we would have the equation y equals 0, which is a horizontal line, which we don't want. Okay, b has to be greater than 0, or the graph would bounce above / below the x-axis, which isn't necessarily a constant motion. So we don't want that. And our last stipulation is that b cannot equal 1. Otherwise, you would have y equals a, which would be a horizontal line. Okay, so if you have any questions, ask. I know this was a lot of information. We will be continuing to work with exponential functions for the next couple of days, okay, and practicing our graphing skills and all that good jazz. Make sure you have this video watched and completed for tomorrow, and we will start exponential growth and decay. Have a great night.